Good morning or good afternoon, depending on what time this video is being presented. First of all, I want to apologize for not being able to attend the HSSC meeting in person this time, but an impromptu meeting with a customer here in Redlands, California this week made me change my plans last minute. I was really looking forward to meet you all there and participate at this important meeting. At the same time, I want to thank the IHO Secretariat, the HSSC Chair, and the Finnish Transport and Communications Agency for allowing me to present ESRI's perspective to the dual fuel issue through this video that I hope you all find useful. I want to start here with a brief overview of the ESRI maritime technology to give you some context to the ESRI approach. We can divide ArcGIS in general in three main types of systems or functions. A system of records, what we know as databases to store, manage, and produce data and information. Our ArcGIS bathymetry solution and our ArcGIS Maritime desktop solution are included in this category. Then a system of engagement, what we understand as a system where different users can engage and collaborate, exchange data, and benefit from each other's knowledge. Our ArcGIS Maritime Server extension is included in this category. And finally, a system of insights, where we understand uh, uh, as a system to analyze data, identify patterns, understand geospatial situations, and like how the real world is, and predict and geodesign how things should be. Taking advantage of and leveraging these three types of systems is what we call the geospatial enablement for information superiority. From the standards perspective, to make sure ESRI complies with the needs of the hydrographic community, we actively participate in several IHO working groups and project teams. We are fully committed in supporting the IHO members, and a proof of that is the issuing of the first S57 to S101 converter a decade ago. This converter was a free download for many years and used during the testbed project, and now is part of the ArcGIS Maritime desktop solution. So what is the ArcGIS Maritime solution? It is a production system for generating navigational charts that follow the IHO and other international standards to produce ENCs, inland ENCs, bathymetric ENCs, additional military layers, digital nautical charts or DNCs, and any custom marine product required. It contains all the validation and workflow tools that users need to be able to import, edit, export, manage, and publish nautical data and products. Most of the tools are geoprocessing tools, so things like importing, exporting, and validation can be automated. And workflows to track a unit of work from the creation, the in-progress status, quality control status, complete, and finally published. So today, the S100 geoprocessing tools allow users to script various processes together, including our S57 geoprocessing tools that allow you to edit S57 datasets, then export and convert that to S101 and import your newly converted S101 datasets into the ArcGIS S101 production database. I will show you these processes in a moment. Like our S57 production tools in ArcGIS Pro, our Maritime ribbon will automatically detect that you are working with an S100 based database and will enable the Maritime editing tools. Our initial focus of the ArcGIS Maritime S100 editing experience is S101, but this will be expanded to the other S1XX products as their respective standards and feature catalogs become available and the priorities from the IHL community established. Here, all editing um, tools are driven by the S101 feature catalog. This ensures that the correct bindings are enabled for the associations as well as attributes and their enumerations. So now, with that in mind, let's take a look at how an S57-based production system would transition to an S101 production system from the ESRI's perspective. Here we are considering the ArcGIS Maritime Enterprise or Central Database, also called the Nautical Information System or NIS, as our starting point. But this starting point could be any other type of traditional central database. The current S57 products maintained in the database will be converted to S101 for a certain period of time. This converted or new S101 ENCs will, of course, only contain the information coming from the S57 data model. All the new features and attributes that only exist in the S101 data model will have to be added later, either manually or using some level of automation. This process will happen during the transition period, where the S101 ENCs will build the new S101 Nautical Information System. This new S101 ENCs imported into the S101 NIS will be deprecated from their equivalents in the S57 NIS and maintained only once, so no duplication of efforts. From the S101 NIS, the old S57 ENCs will continue to be exported as they used to from the S57 NIS, as there will be an overlapping period in the use of the two types of ENCs. And this is the dual fuel system, a single S101 database from which both the S57 and the S101 ENCs can be exported. With time, the S57 ENCs will eventually fade away, and only the S101 ENCs will be needed. We don't know how long these timelines will last, but Esri is committed to support this transition as long as needed. As time goes by and policies change, eventually we will all be in an S100 world. As more S100 feature catalogs are developed and standards finalized, Esri's holistic approach to S100 will allow the support and creation of new databases and the sharing of resources between them. From the more obvious and complementary ones, such as an S102 bathymetric surfaces from a bathymetric information system or BIS, from which the S101 NIS can extract selected soundings and contours for ENC production, so they can be complementary. To others, such as an S121 maritime limits and boundaries that can either get boundaries from the S101 NIS or feed this NIS database with the S121 boundaries, and so on. any other S1XX product database in the hydrographic domain that a hydrographic office is responsible of will be created in the ArcGIS Maritime system. And where data from one is complementary to the other, it will be automatically shared between them, avoiding duplication of efforts. This same concept can be applied to any other SXXX product coming from external sources, from other agencies responsible for producing data in other S100 domains, for example, the Ayala domain. Now, let's take a look at a brief example of working with S101 data. The following are some short video clips that describe basic processes of ingesting the S101 feature catalog, converting an S57 ENC to an S101 ENC, importing an S101 cell into a geodatabase, editing the S101 data in the geodatabase, exporting the edited data to an S101 ENC cell, and finally, publishing the S101 ENC for consumption. In this first demonstration, we are creating the geodatabase based on the S101 feature catalog. This process can be applied to any other feature catalog. With this tool in the Maritime toolset, we import the contents of an S100 feature catalog into an existing geodatabase. A feature catalog is an XML document that describes the content of a data product, in this case, an S101 product. The output workspace is a geodatabase to which output data will be written. This process is what we call the environment setting, with tools that honor the S100 feature catalog and the file environment of that feature catalog that uses the file specified to map objects, attributes, feature classes, and relationships during data import and the creation of database schemas. This tool converts the S57 vector product for storing nautical charting data to the new vector S101 format. If you want to load updates and you do not have a catalog file, the updates must be in the same folder as the 000 file. This allows the updates to be automatically applied during the loading process. Once the tool runs successfully, a log file will be written to the output location with warning and error messages. If an S57 cell has been converted to S101, this new cell can be imported into the geodatabase. With this tool, we import the S101 or any other S100 hydrographic data into a geodatabase created from a related S100 feature catalog. In this case, as we just saw, the S101 feature catalog. The S101 ENC is imported to the target workspace, which is the geodatabase to which output data will be written, and in this case is the one called S101 underscore FC dot GDB that was previously created. Now, let's make a small edit to the recently created S101 geodatabase. In this case, we are going to reshape a contour line, something that could be the correction of something or motivated by new bathymetry coming in, or any other reason. So we start the editing tools. Then we are selecting the tool needed, in this case, to reshape a contour line. We select the layer and the line object we need to modify and give it the new shape. And once it is done, we simply just save the changes. Now that we are finished with edits to an S101 geodatabase, we need to export the changes to the actual S101 product. This tool exports the S101 data from a geodatabase to an S101 file. S101 products are clipped and extracted based on the area or areas of interest, that can be up to 3, pursuant to the S101 specification in the product coverage feature class in the geodatabase. There are 2 criteria that must exist to export an S101 cell. Number 1, product information must be populated in the product definitions table. And number 2, there must be at least one area of interest in the product coverage feature class with a relationship to the corresponding product definition. The type of file created during this export is a new edition, which is a new edition of a dataset, including new information that has not been previously distributed by updates. This is the default setting. Once the S101 product has been exported, it can be seen in the corresponding output location. This S101 new edition now can be published as a web map layer using our ArcGIS Enterprise or ArcGIS Online account. To share content from ArcGIS Pro, you must have an account that is part of an ArcGIS organization that has the privileges to create, to update, and to delete content. In this case, we are publishing the Annapolis Match demo layer that was just created in the Maritime desktop solution from our ArcGIS Online account. Then we open the NOAA ENC service that uses the ArcGIS Maritime Chart Server extension to display the current published ENC data in the S57 format, and then bring our web map layer to the service and compare the existing contour with the newly created one. Applying some transparency and zooming in to check the differences so we can confirm that our edited contour is there, published. So far, I have talked about the system of record, which I consider the main focus of this discussion. But please keep in mind that production is not the end. It is one very important step from converting data into knowledge. That knowledge is multiplied when you move into the system of engagement for distribution, sharing, and collaboration. And hopefully, when you have this data and products available, you can analyze and understand their relationships and patterns with time through the system of insights, which hopefully will convert knowledge into wisdom. Thank you for your kind attention. If you have any questions or comments, please send me an email and I will be happy to get back to you as soon as I can. Enjoy the rest of the meeting.